Hello, everyone. Thank you so much for joining me today for my webinar on smart railway monitoring. My name is Amber Brown, and I am the North American Sales Director for Move Solutions, and I will be your host and guide today for the discussion that we're having on railway monitoring. So I know there are a lot of people from all around the world, which is amazing. So to give you a little background on Move Solutions, for those of you that have not worked with us before and are new to learning about our solutions, we are a company that designs and manufactures structural health monitoring sensors. But what we have been really focused on is providing solutions to the customers. So we've worked very hard on having complete solutions for different types of structural health monitoring. So in this case, we have a full solution for railway monitoring. So from the installation to the data analysis, we have worked very hard on having the best monitoring approach possible, in our opinion. So from the installation, we have wireless sensors, which keeps the installation costs extremely low, extremely fast, also keeps the maintenance costs very low since the batteries last from 2 to 8 years, through to the data analysis. So we have a very user-friendly platform that has specific tools and functions focused on the different solutions for your monitoring. So to get into the webinar, this is the overview of the webinar. So today we're going to be hitting 4 main points. So going over the technology, the different types of monitoring systems. There's some different types out there. We don't do every single type of monitoring for rail, but the types that we do, we feel are really important for the rail market, the advantages and disadvantages of each system, and how to choose the right system for your organization or your project that you have. The key components, so the sensors, the analysis tools, and the data collection and storage. The applications, so the various applications where we use our sensors the most, where they make the most sense, and where our customers have the most needs. And also the best practices. So planning and preparation to installation, to the data management and interpretation, and the overall ongoing monitoring. So to get into the technology, so there are many types of different rail monitoring systems out there, and sometimes it's appropriate to use others over others, but some of the main ones that we see the most are these 4. So the first one is ultrasonic rail testing. This is using high frequency sound waves to detect cracks and breaks in the structure. And this is not something we do. It's something important in the rail industry, but the benefit is that it's a great monitoring, and the downfall is that it's a short-term monitoring. So you can perform it real time, but after that moment of time that you're performing it, you have no analysis of how the track is behaving after that. The second is the track geometry measurement system, and this is what we're really focused on, is understanding the geometric parameters of the track. So the twist, the cant, the vertical deflection, and understanding how that track is behaving. And the nice thing about this system is that we're using our sensors, which monitor in real time, 24/7. So it's something great. You can use it with the first one that I mentioned as an in-between monitoring. You have constant data and a constant understanding for how your track is behaving. The third is video monitoring systems. This is something we see quite commonly, is either adding video to systems such as ours, but a video monitoring system is best used when you have a specific scenario of understanding security, if you have it in a certain area where you want to understand, if there are people on the tracks, collision detection, things like that, where you have specific things you're looking for with the video monitoring. But it's never going to replace the data that you're getting from sensors. So it's something that's a good add-on to the system, but you're never going to get the data that you need to really understand the geometric parameters of the track. And finally, geotechnical monitoring systems. So this is another area that we're very focused on because understanding the tracks is really important, but also understanding the geotechnic parameters around the tracks is just as important too. So understanding what's happening on slopes or embankments near the tracks or groundwater, strain, any of those geotechnical parameters that have an effect on how the track is behaving is something else that we look at and feel is very important for rail monitoring. So why Move Solutions? I know we have a lot of people on here. Some of them are our customers. Some of them are using other systems. So why stay with us or why pick Move Solutions? So I think the most important point is our sensors. So we have both a static and dynamic monitoring system. So we have both static sensors, which thinking about rail monitoring, you typically think about a static monitoring. So looking at the static parameters, the twist, the cant, the vertical deflection, which are all really important, and that's something that we do. But another level is looking at dynamic parameters in certain cases. So having a system that can do both static and dynamic monitoring is really important because you can expand your monitoring so much. So if you're monitoring the rail tracks, but you also have a rail bridge, you can monitor the tracks and the bridge dynamically. So maybe you want to look at the frequencies, shapes, and damping of the rail bridge along with the rail tracks. And that's something that you can do with our system since we have our dynamic sensors. Or if you have a construction site and you need to understand the vibrations of the construction site and how those are affecting the tracks, you can add our vibrometer onto the construction site or the tracks to understand how the vibration is affecting them. So having both the static and the dynamic is something so important and gives you such a deeper level of analysis with your monitoring plan. Also, we have software as a solution. So we have an interface developed with a user-centered design approach. And what's important about that is that you don't need to have a deep level of understanding of data. We have all of the raw data, but we have all of the tools and algorithms and functions to give the data to you in the easiest to understand way. So I will get into the platform later. I'm going to screen share the platform to show you how easy and simple it is to understand what's happening with your rail track. And that brings me into the last point, which is our algorithms. So we have algorithms for all types of structures. So in this case, we have the algorithms and tools for rail monitoring. But as I mentioned, if you're also looking at a rail bridge, we have specific bridge solutions and specific bridge algorithms. So you can bring all of that data together and see it in one place. There we go. So to get into the key components and talking about the geometry of the track in that system. So what we use is our tiltmeter to do so. And the tiltmeter is a small wireless sensor that's monitoring the angle of inclination. And so the first parameter that we look at is the cant parameter. And so we typically add a tiltmeter onto the railroad tie or sleeper, depending on where you're at. And what we're looking at is the transversal slope of the track. So I'll use this marker. So what we're looking at, if this is the tie, is how it's moving in this direction. And then we also have the twist parameter. So we're using multiple tiltmeters installed on the railroad ties, and we're looking at the difference between those two parameters in terms of cant. And so you're able to understand how that rail track is moving. So there could be some twisting depending on how those railroad ties are moving. Next, we have the vertical displacement parameter, and this is understanding if there's a deformation of the tracks on the vertical plane. And so how we do this is we add a chain of tilt beams, which is exactly how it looks like there. It's a long beam that you can install on the ties themselves or right next to the ties. And we put a tiltmeter in the center of it. We chain them together and we can rebuild that line and understand that vertical deformation of the tracks. Finally, we have the geotechnical monitoring system. So how we do this is by using our wireless analog node, which is a device to connect the third-party probes. So if you're trying to measure the strain, a extensometer, an inclinometer tube, a weather sensor, a noise or dust sensor, all of those third-party geotechnical probes that you use, you can connect into the node. It becomes wireless, so there's no wiring, it becomes wireless itself. And then it integrates that data into the system. So you're able to understand how those parameters are affecting the railway monitoring altogether. We also use our tiltmeters for geotechnical monitoring. So a common application is using our tiltmeters installed on poles driven into the ground for slope monitoring. So you're able to see if there's a slope or embankment near the tracks, you're able to track that closely and understand if there's movement of the slope, a washout, and understand if things, are moving into the tracks based on the alarms you set on the tiltmeters. So moving into the common applications. So these are the most common applications that we see. I'm sure there are others as well, but these are the most common ones that we typically create monitoring plans for. And the first one is inspection. So real-time monitoring can improve the efficiency of inspections so much. So if you're performing routine inspections, having data in between can completely change your inspection planning. So if you have certain areas that are at higher risk and you have to perform inspections more often, by having a system in place, you can either understand if there is no need for an inspection because there has been no movement, or if there are problems and you're seeing movements, you can understand exactly where the problem is at on the rail track. So you're able to focus your inspection in the area that it needs to be by having the data that is coming to you every day and showing you where the changes are happening. As well as maintenance. So advanced maintenance planning is something that's becoming more and more common. Having a system that can detect failure and help you understand the failure points helps with your maintenance planning. So say you have maybe 3 sections of track that you need to perform maintenance on, maybe some need to be replaced. You can monitor those and you can prioritize your resources where they're needed the most. So if you see that one section of the track is moving and you need to focus your investigation there while monitoring the other sections and understanding that there has been no movement and you can hold off on those for now and focus on the areas where there's the most concern. And finally is construction. In North America, this is definitely the most common application that we see in the rail market. And it's typically when there's construction near a rail track, on the rail track, above it. And when that happens and trains are still operating, it's really important to understand if there's movement of the tracks to prevent derailments for public safety. So understanding if those are moving while you're performing construction. So getting into the best practices with planning and preparation. So something that we do at Move Solutions is we follow our customers from start to finish. So typically what happens is we have a customer and whether they have specifications or some certain needs to monitor the rail tracks, we will put together plans based on the specifications and the needs of the customer. So depending on what they're looking to monitor for, we'll put together a customized plan for that project. And so this is an example of a very common scenario, as I mentioned, with construction near a rail, or in this case, a rail yard. And so As you can see on the left-hand side, we have the construction area, which with our sensors, you can monitor the actual construction site. So whether you're using geotechnical sensors on the construction site, maybe you're monitoring the noise and the dust, you can use our vibrometers to monitor the vibrations from the construction site to make sure they're not exceeding a certain threshold that could cause damage to that wall or the rail track itself. So you can actually monitor that site. In this case, there is a wall, which is right next to the rail yard. So in that case, you can monitor the wall. You can add tilt meters onto the wall to see the inclination of the wall, if there's any movement of that wall. Crack meters, maybe there were some pre-existing cracks that you want to ensure are not being affected by the construction. You can add crack meters into the nodes and monitor those as well. And then also you can monitor, of course, the actual rail track itself with the tilt meters. You can do the twist, the cant, and the vertical deflection. And I think this is a really good scenario to talk about and to highlight our sensors and how it can make a scenario like this a lot easier compared to other methods out there. You know, their total stations are commonly used for monitoring the geometry of a track, and they work great. But the problem when you have congested areas like this, where you don't have lines of sight, you end up having to put a lot of total stations or having someone come out and take the manual measurements. And that's something that's really expensive and not easy to do in scenarios like this. So having a small wireless system that you can leave on the track all the time, you have 24/7 monitoring, can actually save a lot of time and a lot of money when talking about a monitoring scenario like this. And getting into the planning and preparation still, but how to actually install the sensors. So with new customers, they're always so worried about the installation. They, ask a lot of questions, which is great. And they get a little worried about the installation and the configuration and setting everything up. But it's actually extremely simple with our system. So we basically have 3 steps. The first one is setting up the gateway. So the gateway is the communication device, how the sensors send the data to the platform. And this is installed with power. So you either connect it to power or a solar panel, and you use either a SIM card or an Ethernet line. So whether you have direct internet access or cellular, you can connect it either way. Once you get that up and running, then you want to install the sensors, which they come with a mounting bracket already. You can either bolt them on the structure or epoxy them if you don't want to drill into the structure, which I know is quite common on rail tracks. They do not want you to drill into them. So you can simply epoxy them onto the track. Once the sensors are in range of the gateway, so once the gateway is up and running, the sensors are always in a sleep mode. So they wake up every 25 minutes, they look for a gateway. If they don't find one, they go back to sleep. So once you install the sensors and you have that gateway up and running, as soon as they find that gateway, they are going to be up and running and transmitting the data to the platform. So there's no configuration or setup in that sense. And then finally, what you do is you go to the platform and you look at the status of the sensors. So you can see if they're online or offline, and then you can start seeing your monitoring. And that takes me to the Move Cloud platform, which I'm going to show you in real time. Okay, so I hope everyone can see that okay. So this is our cloud platform. So you would have a login information, a username and password for your project with the sensors that are loaded into that platform for your project. So when you log in, you're going to see something like this. Actually, you won't have a picture and the sensors will be to the right. So you can upload your own picture. You can just edit the image and upload whatever picture you have, whether it's a real picture like this, plans, drawings, a map. You can put that right on the platform. You can move your sensors around and put them where they're located in real life. Now, with rail tracks, it's a little more complicated because they're typically pretty long. So getting into the tools for our rails. Okay, so this is the the specific tool for rail monitoring. So as you can see here, we have one section, but you can add as many sections as you would like. So you can see here, you have one section, a total of 20 sensors in a length of 100 meters. So it's simple to add a section. You can just go here, add a new section. So you can give the name of the section. I'll just give it move, the direction of the railroad. So if it's going south to north, whoops, description, and then the length of the section. So maybe the section is 50 meters in the distance between the rail tracks, and that's the distance basically of the railroad ties. So between each track, so maybe it's 1 meter. And then here you can add your sensor. So you can add a sensor. All of the sensors that are not in a section will populate here. They're all in a section. So I don't have any to actually add, but you'll see a list of the sensors that you haven't added to a section. And so you can easily add them into that section. And then next we have the tilt beam chains, And so this is for that vertical deflection. So you can add a new tilt beam chain, you can name it, you put the length of the beam, and you can add your section of tilt beam chains. I'm going to go back. Okay, so, I have to go back one more. Okay, so what you do is you select the section that you want to see the data and you scroll down. So as you can see here, there's the 3 categories. So the cant, the twist, and the settlement. On the left-hand side, you'll see all of the events. Up here, you can pick your date range. So you can pick as long or as little as you would like. So this is the 2nd to the 9th. So here you will see all of the events from the 2nd to the 9th. Now, this is showing you the cant. So as you can see in millimeters, you can see the cant and which sensor that is associated with the EUI. Here, this is a single event. So a single event from that section, and our sensors are synchronized. So the tiltmeters are synchronized. So they're taking those synchronized acquisitions on the cadence that you set. So this is set at every 20 minutes. So every 20 minutes, it's taking those synchronized acquisitions where you can find them here, and then you can see each acquisition here. Something interesting is that you can actually categorize it by the intensity. So if you want to see the biggest value in cant, you can actually select it here. And so that way it makes it easy to understand where the problem is on the tracks. So you're not trying to look for the problem through a ton of data. You can categorize it by, the biggest to the smallest or the smallest to the biggest. And that way you can select that and find, okay, this is, a huge event. And that way you can look at that specific sensor and see what's going on with it. Going down, you can see the cant over time. And so this is interesting because here you have, the single acquisition, but if you want to see, okay, this sensor, which is 30796, you want to see how that has behaved over time and the trend, you can go down here and you can select that sensor. 30796. So you can see the evolution. So you can see if it was slowly going up over time or if it was a big event like this. And you can see the trend over time with the date range that you choose. You also have the temperature trend. So you can, all of the sensors have a temperature sensor inside. So you can also see the temperature trend of the sensor as well. Next, we have the twist, which is quite similar visually as the cants and operationally. So you can see the twist in the same way, but instead you'll see the twist for the sensors that are grouped, within that section. So this would be off of 2 sensors. So you can see the EUIs and the 2 sensors that it's taking that twist percentage from. And same on the left, you can categorize it by the intensity of the twist. You can find the biggest event. And you can also see that over time as well, depending on the time frame that you choose. Also, when you have two sensors, you can see the temperature trend of both of those sensors over time and with both sensors. And the settlement, we actually don't have, oh, we do have settlement. I didn't think we did on this, but the settlement is very, very similar, where you can see the settlement in this sense. So you can see the millimeters of settlement, and you can find each of the events on the left-hand side and categorize those the same way. So I am going to, yep, we have 4 minutes for questions. So I am going to go back to this. Let me see. Actually, I'm going to get out of that. I'm just going to stop sharing. Okay. And see if anyone has questions. So while inspection, how do we know the exact location where repair or maintenance is needed? So when you're installing the sensors, well, typically the customers have, a map of where the sensors are installed. And so when you're looking at those graphs, which maybe that kind of answered the question, you can see exactly which sensor has, the highest value in terms of twist cant or vertical settlement. So based on, the sections that you've set up and the map that you've made, you're able to know where the sensors are located. How do we ensure there's uninterrupted power supply for those sensors? So the sensors are battery powered. So they're uninterrupted until the battery dies, of course. So when the battery dies, you would have to change that. The most important is on the gateway side. So the sensors are going to communicate with the gateway. The most power problems are with the gateway. So typically, if you're worried about power, you can always add a backup battery. So if you're on solar, you can have additional batteries. If you're on power and there's a power outage, you can have, a small backup battery that will run if there's a power outage. Please mention sensing range of those sensors. So those, in terms of the tiltmeters and the inclination, it's up to 90 degrees. Could you please give some cost ideas for a particular duration? So 6 months, 12 months. So the costs vary. Well, the costs vary depending on the project, how many sensors, and also we use distributors around the world. So the cost will vary a little bit. If you have a project, definitely reach out and we can connect you with your closest distributor. But the sensors, typically, the sensors have a cost. They're pretty low cost. I would say general ballpark would be around $500 US up to, for the tiltmeters. And then the dynamic sensors are a little bit different, but just talking about the tiltmeters, but they vary, depending on where you're at. And then you have a platform charge yearly. So if you have a project in mind, definitely you can send us an email and we can connect you with your distributor and set you up with, some pricing for a particular project. Do you know if the nodes are approved for network Braille use in the UK? I'm not sure. It's not my territory, unfortunately, but if you reach out to us, I can put you in touch with our sales director in the UK. Who can definitely answer you the questions specifically, for network Braille. How long does the battery last? So on the tiltmeters, it depends on how you set the cadence. So if you're doing, it goes down to 30 seconds up to every 30 minutes. So if you're doing 30-minute samplings, you're around 8 years of battery life. And if you're doing 30-second samplings, then you're around 1 year of battery life. And then in between there, it kind of spreads out. So I would say typically, if you're doing the acquisitions every 15 to 30 minutes, then you're in like the 6 to 8 year range, which definitely keeps the maintenance costs low. When it's time to change the battery, you can do so yourself. It's a commercial battery. Is it possible to know wear and tear of rails? I'm not sure in what sense. So the parameters that we're looking for are the twist, the cant, and the vertical deflection. I know there are some third-party probes that people use commonly in rail monitoring, such as strain gauges connected to nodes. So there are different options that some of our customers have used connected to nodes to understand different parameters of the rail tracks. Global monitoring is possible with these sensors. Please mention cost benefit analysis too, how you decide the placing of sensors and locations. And what about piezoelectric sensors? So global monitoring is possible. We use the LoRaWAN communication system. So we have the bandwidths for basically the entire world. I'm not sure if it's 100%, but I would say 99% of the world, we have the frequencies and bandwidths for the LoRaWAN connection. So you can use them all over the world. The cost benefit is that the sensors themselves are low cost, and definitely reach out and we can connect you with the distributor to give you the cost breakdown. But also the installation costs are extremely low because instead of, spending days wiring up systems along, long rails, you can just simply either bolt them or epoxy them. So you definitely have a much shorter installation period, which is, less manpower and definitely saves you on cost. How do we decide on the placing of sensors? So we have a pre-sales office of structural engineers, and they will look at the project and give you a recommendation on where to place the sensors. And what about piezoelectric sensors? I'm not familiar with that. I'm not sure. I can find out, but I'm not super familiar with that sensor. I'm sorry. Can a permanent offset be applied to the incoming cant measurements? This will allow for computation of absolute twist and not only relative. I am not 100% sure. I know we can provide a permanent offset on the tiltmeter. So I want to say yes, but I'm not sure if it is directly translated into the cant. But I can definitely find out for you. Is there something like, oh, yes, it is. The product manager texts me. So yes, you can apply a permanent offset to be applied to the cant measurements. Is there something like automatic alerts for overcoming thresholds? And another question, is it possible to send monthly report? Something like automatic alerts for overcoming thresholds. Yes, exactly. So you can set, so we don't currently have the alerts on the cant and the twist, which we're adding those. So those will be here very soon. But we do have alerts on the tiltmeters. So you can set those on certain values and be alerted if it's over a certain threshold. And then is it possible to send a monthly report? So we don't have a monthly reporting system in the platform, but you can download all of the data in a CSV file. So if you want to download it, on your own every month, but it's actually something we're adding monthly reports into our next update of our platform. So that's something that you will definitely see in the very near future. Do you also have sensors and solutions to monitor the horizontal deformation of position of the rail track? No, we don't. We want to, because that's definitely an area that is not easy to monitor, is the horizontal movement. It's something that we're working on, but for now, we cannot do the horizontal plane. How long will it take to collect and process the data from sensors and visualize on cloud? So it takes about 2 seconds, I believe, for the data to get from the sensor to the cloud. So it's almost instantly. Can you rearrange the output screens to your own preferences, or are they fixed? They're fixed for now, but you guys are asking a lot of common questions that we're implementing into our next platform update. We will have a customizable dashboard where you can basically pick the graphs that you want to see on your main dashboard. So that's something that we're implementing as well. Global monitoring, yes, it's possible. Is it possible to include also other sensors or manual leveling data in your monitoring platform? So really the only other sensors that we can implement into our platform are what's connected with the nodes. So our nodes have 8 different interfaces. So, I mean, they vary from vibrating wire, 420 milliampere, potentiometer, millivolt over volt. There's some other ones. But if you're looking to implement like a total station or a completely different type of monitoring equipment, no, we can't implement that into our platform. We do have different partners that we have integrated our sensors with. So we have our API connection. So if you have a type of platform that you use with many different types of sensors, then we can integrate our data into other platforms. So if you have to use other sensors, you can still use our sensors as well. Would the battery life change with cold weather? I mean, it definitely affects it slightly, but they're certified to negative, oh, I forget. I want to say negative, let me find out, negative 40 degrees Celsius. So they're certified to negative 40 degrees Celsius. So definitely if you go below that, it could have an effect. But up to that point, it shouldn't have an effect. Do we have access to the same data on the platform with the old sensors, which aren't able to be synced together? Yes, of course. So if you have the version 1 Tiltmeter, which doesn't have the synchronization, you can still use all of the tools. The only difference is that the data isn't synchronized, but you're still going to see the twist and the cant in the vertical settlement. So you can still have access to all of that. Since settlement numbers are relative, how can you find the absolute settlement? Example, a train is parked over the area with sensors and the entire length settles evenly. Yes, I mean, it's still a relative measurement. And so if you have some specific scenario like that where it's parked and you see a settlement, then you're going to see the settlement of the track. And I mean, that's kind of a hard question to answer for me, but it is relative. And typically you want to start the chain at a point where you don't expect the settlement. And so that way you have a fixed point and you can understand the broken line from there. But if you do have something sitting on the tracks, then you're going to see an event from that. But it wouldn't be permanent though. So you would see, in that case, you would see a special event. But once the train moves, then you would see it go back to, where it was previously. So sensors need to be connected with internet, right? Yes. So you can connect them with a direct Ethernet line to the internet. You can connect the gateway to Wi-Fi. Or you can use a SIM card for cellular connection. Am I sharing the presentation with subscribers? Yep, absolutely. You will receive a recording of the presentation. If you want just the presentation, then you can reach out to us and we can send you just like the hard copy of the presentation. If there is no cell coverage, what are the alternatives? So they have been tested by one of our distributors with the Starlink satellite system. And so if you have something like that, like the Starlink satellite, that was tested with the sensors in the gateway and it worked. So if you have if you're in a very remote area and you do have access to satellite with one of those devices, you could use that. How many sensors can we have to a single gateway? So if we're talking about the tiltmeters and, the node dynamic sensors, then you would be around 50 sensors per gateway. Depending on the area, line of sight, some different things affect that. If you're adding in dynamic sensors, it may go down a little to like 40. Maybe you could even get up to 60. So it kind of depends on, the area, but I would say, around 50. Can you get data via API into another platform? Yes, exactly. So if you have another platform and you want to integrate the sensors, then you can certainly do so. We have the API connections, and you also have access to the tools that we have as well. Will sensors work on adverse weather too? Yes, I mean, we have sensors in some pretty harsh climates in Canada. They used to be in Russia. So they definitely, they're certified to negative 40 degrees Celsius and plus 85 degrees Celsius. So in harsh environments, they're also IP60, IP68. So they're dust proof, particle proof, waterproof. So if you have a lot of rain, a lot of dust, dirt, they're sealed off from that. And I think that's all the questions. If anyone else has any more, I appreciate all of the questions. I really do. Oh, maybe there's some over here. Okay, so there's one question in the chat. What is the highest measurement frequency that we can reach and how much battery? Okay, so the highest the highest measurement frequency would be every 30 seconds, and that would be around 1 year of battery life. And then can we set the threshold with SMS or email? So with email alerts, you can set the alarms. Okay, so I think that's all of the questions. I really appreciate everyone that came today and asked all the questions. And I hope you guys are interested in trying the system. If you have any projects, please reach out and we would be happy to put together a monitoring plan, get you pricing, and show you what it would look like to monitor your project. So thank you so much. Have a great rest of your day.